Good afternoon to one and all. I am now going to take the next chapter of General Physics, BSc second semester 3. This chapter is Precessional Motion. Myself, Dr. R.N. Mulik, I will take this Precessional Motion to you. Now, as far as content of the chapter is concerned, it includes basic idea of the precession, what is precessional motion, then comes to gyroscope, nutation, Lanchester's rule, gyrostatic pendulum, motion of a rolling disc, and gyroscopic applications. As far as the introduction of this gyroscopic motion or the precessional motion is concerned, we will understand basically the principle behind the precessional motion and how this motion is governed. Working of a gyro compass for navigation of ships and aeroplanes, directional stability of firing bullet, etc. The principle of precessional motion is very important and this is applied. As far as the directional stability of moving vehicles like ships, aeroplanes, here the firing of bullets when takes place, the directional stability for proper direction is important, and this is achieved by the precessional motion or the principle of precessional motion. Study of the precessional motion plane vector is essential. The physical quantities like velocity, acceleration, force, etc. can be represented by vectors called as linear vectors. As far as these quantities are concerned, velocity, acceleration, force, they are supposed to be the linear vectors. When we study the dynamics or rotational dynamics, in case of the rotational dynamics as represented by the plane vectors, a plane vector is two-dimensional with one dimension as a plane of rotation and the other is the line of action. When we study the example of that, that is angular velocity, angular momentum, torque. These are the quantities such that they are performing motion in one plane and its direction is obtained in the perpendicular direction to the plane containing these motions. Now, as far as precession is concerned, the plane of rotation is called precession. The body when rotates, when body performs rotational motion, the plane described by the body is called precession. The precession is caused by the couple or torque acting on the plane perpendicular to the rotation of the body. Now, as far as precession is concerned, the torque is must for the precessional motion. For the precession, torque is necessary. Unless we have the torque acting on the body cannot perform the precessional motion. How torque is essential, it is necessary for precessional motion. We will study this and we will see that how torque is required for the precessional motion. For that, let us consider a disc DD in the form of a cross section as shown in the figure, revolving with a constant angular velocity omega. Let the plane of the disc is perpendicular to the plane of paper and along the axis x, y dash. The plane of performing the rotation of the disc is along the perpendicular axis x, y dash. I be the moment of inertia of the disc. Obviously, I omega will be its angular momentum because omega will be its constant angular velocity. After precession, the disc takes place d dash, d dash, d dash, making an angle phi theta within the original position in time dt. As time passes, within a small time interval dt, the angle traced by the disc is phi dt. Then the change in the angular momentum of the disc is represented vertically by A dash, which is equal to I omega dot phi dt. We can determine A dash in the figure. The distance A dash can be obtained as I omega into phi dt. The change is done in time dt. This is obtained within a small time interval dt. Rate of change of angular momentum of the disk, which is equal to I omega phi dt upon dt. Rate of change, that means we have to calculate per unit time. It comes out to be I omega into phi. Since the rate of change of angular momentum of a rotating body is equal to the torque, therefore precessional torque tau 1 is equal to I omega into phi. Rate of change of angular momentum is known as precessional torque. Tau 1 is equal to I omega phi. Therefore, rate of precession phi is equal to tau 1 upon I omega. That means this equation consists of precession is directly proportional to the applied torque tau 1 and inversely proportional to the angular momentum I omega of the body. Now these are the next part will be the examples of the precessional motion, how the principle of precessional motion is helpful as far as the gyroscopic motion is concerned. That part we will see in the next period. Thank you.